Hello and welcome back. In the last lectures, we've discussed what ARP poisoning is and how to execute an ARP poison attack using both Ettercap and Bettercap. Let's recap in just a few words what was all about. A man-in-the-middle attack of type ARP poisoning is achieved when an attacker poisons the ARP cache of two devices with its own MAC address. Once the ARP cache has been successfully poisoned, each of the victim devices sends all their packets to the attacker when communicating to each other. This puts the attacker in the middle of the communication between the two victim devices. Hence the name man-in-the-middle attack. It allows an attacker to easily monitor all communication between victim devices. The purpose is to take over the session, intercept and view the information being passed between the two victim devices. Let's go ahead and see the techniques to mitigate this attack. We divide these techniques into categories. There is a central solution for the entire LAN which is implemented on the switch and is called Dynamic ARP Inspection or DAI. It has a dependency on DHCP snooping which must be enabled. The DHCP snooping feature is covered in more details in another lecture. Dynamic ARP Inspection is a security feature that is available on professional networking devices like Cisco switches. It helps prevent ARP poisoning and other ARP-based attacks by intercepting all ARP requests and responses and by verifying their authenticity before forwarding the packets to the intended destinations. The switch creates a trusted binding table of IP and MAC addresses and then discards any ARP packets that are inconsistent with the information contained in the binding table. This binding table is dynamically populated by DHCP snooping or statically by admin for static IP addresses. If you activate Dynamic ARP Inspection and DHCP snooping on each switch and the possible attacker starts an ARP poisoning attack, the switch will not forward to the hosts the ARP reply packets that associate the IP of the victim to the MAC of the attacker. It will verify each intercepted packet for a valid IP to MAC binding. I will not show you how to configure it because it's not the purpose of this lecture, but I'll attach a full documentation of how to do it as a resource for this lecture. Besides Dynamic ARP Inspection, which is a solution for enterprise networks and involves expensive switches, there are also local solutions that can be applied to each individual host. Let's take a look at these solutions. First, I'll start an ARP spoofing attack using Ettercap. Ettercap -t-m ARP and the victims, the default gateway and the Windows machine. Okay, the attack is running. Now, on the victim, I'm displaying the ARP table. ARP-A. And we notice how the MAC of the attacker is associated with both the default gateway and the attacker. By inspecting the ARP table this way, you can become aware that you are a victim of an ARP spoofing attack. But let's be honest, who would continuously check the ARP table? It's not only impossible to do it on a regular basis, but also annoying. The good news is that there are tools that automatically monitor for you the ARP table and generate an alert when something bad happens. You can see here a lot of tools that do this. One well-known tool is XARP, which works both on Linux and Windows. There is also a very good tool called ARP Watch for Linux-based systems and I have used it successfully many times. Let's download and install XARP on the victim machine. Download. I'm downloading the Windows version and I will install it. And I'm running it. Okay, we notice that XARP has generated an alert saying an ARP spoofing attack is running. This is the alert. Okay, it noticed that the MAC address for this IP address, the default gateway, changed. This is what XARP does. It alerts you when something bad is happening. I'm stopping the attack. Let's move on and take a look at another solution to mitigate the ARP spoofing attack. You can use static ARP entries to combat spoofing and man-in-the-middle attacks. Static ARP entries are IP MAC bindings that are manually added to the cache table for a device and are retained in the cache on a permanent basis. When this is done, the OS will ignore all ARP responses for the specific IP address used in the entry and use the specified MAC address instead. You need to create ARP table entries for all of the devices on your LAN, and this is not scalable. If you have n devices, you must create in total n times n-1 divided by 2 entries, or if you have 10 devices, you have to create 45 ARP entries. You can automate the process by using scripting, or you can at least protect the default gateway or the main server. At the end of this lecture, I'll show you how to detect different protocol anomalies, including an ARP storm, which is in fact a kind of network scanning. Let's open Wireshark. And I'll go to Edit, Preferences, Protocols, and I'm searching for ARP. And I'm selecting Detect ARP Request Storms. Okay, and I'll start the capture. I'm returning to Kali and I'll run NetDiscover. NetDiscover is a reconnaissance tool used to detect online hosts or search for them by sending ARP requests. It's scanning the network with ARP request packets. Okay, these are the hosts. Let's return to Wireshark. We see a lot of ARP packets. Let's stop capturing packets. I'll go to Analyze, Expert Information, and we see here useful information, including information about the ARP attack. ARP packet storm detected, and the number of ARP packets for the past 100 milliseconds.